Alright, so for this video, we'll be discussing a past year for October, November 2021 and paper 6.2. So let's have a look for the first question. We are given the mass in kilogram of a block of cheese sold in the supermarket. It's denoted by the random variable M. So the masses of random sample 40 blocks are summarized as follows. So we are having the 40 blocks here. It is actually a sample, right? Okay, so for this 40, it will be our N. So they give you all the information here. N equals to 40. Summation of M is this value, and also summation of M squared is this value. So calculate the unbiased estimates of population mean and also the variance of M. So highlight the keyword unbiased estimates. Basically, when you see this question, right, you have to use the estimation formula to find out the mean and also the variance. So what's the formula? Just a very quick recall. It is provided in the formula booklet. So if you're interested, you can have a look from the MF19. Alright, so I will just write out here so that it's easier for us to estimate, okay, to refer. Okay, so let's have a look for the formula of the mean. So basically, the mean formula is very straightforward. We are taking the summation of x divided by n. So for our example here, it will be summation of m divided by n, okay? Then how about for the variance? So the estimated formula for the variance is 1 over m minus 1. Then you have to take the summation of x squared minus the summation of x whole thing square divided by the sample size. So these are the formula. And to be honest, this question will be very straightforward because of you just apply your value inside the formula and you can get the answer. But of course, you need to know what is the correct formula to be applied. Alright, so to calculate the mean, according to our formula here, I have to take summation of m divided by n, so divided by 40. Okay, so when you press the calculator, by right, you'll get a value 0.5125. So you can keep your answer like this in 4 decimal places because it is not a super long decimal answer, right? So you can keep it like this, no problem. Or if you want to make it become 3 significant figure also can, which is 0.513. Or if you want it to be safe, then you can just keep it as a fraction form. So the fraction form for this one will be 41 over 80. Alright, so this is how we get the value for the mean. It is a straightforward question, yeah. Just apply the formula. Alright, okay, then let's look for the variance. If I want to estimate the population variance, the formula is as shown here. Okay, so 1 divided by n minus 1. What do I have here? It should be 39, right? 40 minus 1. Summation of x squared, I'm applying summation of m squared here. Minus summation of x, then you square it. So I'm going to square the 20.5 square, 20.5, and then divided by the sample size 40. Then again, just try to press calculator. If I'm not mistaken, this value will be slightly longer. I don't want to keep it so long, so I just keep it as a fraction form. So by right, the answer should be 87 divided by 156,000. Okay, so if you want to leave it in the decimal form, then please make sure that you put it into a 3 significant figure answer. Alright, so this is how we get the mean and also variance. And basically, they are the unbiased estimates, mean and also the variance for the population. We are using the sample and we estimate the value for that population. These are the formula that we are going to apply. Right? So let's continue to part number B. For part number B, they are talking about the price of a block of cheese, right? Is found using the formula P equals to 11m plus 0.5. Find the estimates of the population mean and also the variance of P. Alright, you already get the mean of the M just now. Right, in the part A, you already get the mean just now, which is 81. Sorry, which is what? I can't remember. Which is 41 over 80, yeah. 41 over 80. And after that, our variance, I put it in this form. The variance of the M is actually 887 over 156,000. Okay, and now we are having another variable, P, where P is equals to 11m plus 0.5. Alright, so let's have a look for this particular equation here. It is actually a linear equation, right, in terms of M, and we call it as linear combination of the variable. And if you want it to be more precise, it is in our chapter 2 of the syllabus. Alright, so just a very quick recall about how to find out the mean and also the variance for linear combination. As an example, like if I'm having EAX plus B, where X is the variable, A and B are the constant. So to get the mean for this whole AX plus B, it should be A. You can pull out the A, then multiply with the expected value of the X, which is the mean, okay, then plus B directly. Okay, then after that, if you want to calculate the variance for AX plus B, how can you get the answer? So basically, when you want to take out the A, the constant A from the variance, you have to square it. Then multiply with the variance X, and the variance B will give you a value 0. Alright, so all these are the details that we learned in chapter 2. So if you already forget, just go back and have a look about all this detail and formula. Right, so this is the formula that we are going to use in this part, because you are having the linear combination P equals to 11m plus 0.5. So let's continue here. Alright, so I want to find out the expected value of the P. So how to get it? It should be E and then 11m plus 0.5. According to the formula that we have here, you can see that I pull out the A, which is 11, then I multiply it with EM, then plus 0.5. So what's the EM that you calculate just now? The expected value for M, it is actually 41 over 80, then plus 0.5. Okay, so continue further to use calculator and get the answer. Should be 491 over 80. Or if I want to make it into decimal form, it should be 0.1375. Or if you want it to be feel safe into 3 significant figure, then it will be 6.14. 3 significant figure, right? Yeah, so by right, this is what you should get. For me, I'm keeping it in the fraction form. Right? And please take note that when you want to substitute the value of expected value of M or the mean of M, please use the original value. So don't use the value that has been cut short into 3 significant figure. You have to use the original value and substitute it here. Alright? Okay, so continue. Variance P. Okay, to calculate the variance P, I will have variance 11m plus 0.5. Again, according to the formula that I show you here, when you want to take out any constant from the variance, you have to square the constant. It will be 11 square, then multiply with the variance m. And then variance 0.5 will give you a 0. So you see there's no b at the back here, right? Okay, then just substitute the value that you get just now. So 11 square multiply with variance is this from the part A. Okay, then again, press calculator, and I think you will directly get a very long decimal value. Then please cut it short into 3 significant figure. By right, you should be getting 0.688. Right, so this is how we solve question number 1. Question number 2. Andy and Jessica are doing a survey about the musical preference. They plan to choose a representative sample of 6 students from the 256 students at their college. So they are in the college, yeah. So they want to carry out a survey. Andy suggests that they go to the music building during the lunch hour and choose 6 students at random from the students who are there. So give a reason why this method is not satisfactory. The standard answer should be it is not the random sample, but you need to maybe explain a bit why it is not a random sample. Okay, so I will write it like this. This is not a random sample. Okay, maybe we should think in this way. What is the word or what is the keyword that tells you it is not belongs to a random sample? So random sample means that you should select the survey, the sample, right, from anywhere inside the college. It shouldn't be focused only on a certain place at a certain time. Right, so to me, the music building is a restricted area that they find out the sample. Another one is the lunch hour is also another restriction that they find out the sample. Okay, so these two reasons cause that the sample form or the sample found is not a random sample. Okay, so you can write it like this. It is not a random sample because the sample only consists of students who study music or who appear at the music building during the lunch hour. Okay, or in the music building. Yeah, so you need to try to figure out one of the reason. We already know that it is not a random sample, so you have to tell them that, oh, what makes you think that this is not a random sample? Okay, so for this question, it is because of they only focus on the students who are at the music building. Okay, there are so many other type of building, right? So they only focus on one building here. Therefore, this tells us that it is not a random sample. Right, so let's continue to part number 2. For part B, okay, now we have to use another method. She numbers all the students in the college from 1 until 256 because they are having 256 students in total. Then she used her calculator and generated the following random number. These are the random number that we have. From this number, she obtained 6 students' number. The first 3 of the student numbers are 204, 162, and also the 7. Let's have a look for this one. What they want you to do is like they want you to continue Jessica's method to obtain the next 3 students' number. When you want to get any number from a random number table, you need to know how many digits you need to read the number at one. Okay, because we are having 256 students, right? When we read the digit, we should read every 3 digits, okay, to complete a case. So as example, let's say first 3 digits that I have from the beginning of the table is 204. That's the reason why the first student number 204 will be selected. The second number is 393, but we don't have the student with the number 393 because the maximum number is only 256. Can you see that? Right? Then how about 162? So next student number will be having the student number 162. 007, next student with the number 7 will be also being selected. Let's choose the other 3. So from here you can see that we are trying to read the table every 3 digits. The next number will be 204. But if you try to have a look for the number before, the 204 already appeared earlier, and we are not going to take this again because the student already in the group, already being selected. Next 3 digit, 028. So my answer will be 28. My next student will be 28. 587. Again, it is already more than 256. We are not going to take this number. Next 3 digit will be 119. Yeah, and 119 doesn't appear earlier, right? The second student will be the 119. Next 3 digit, 207. And it doesn't appear before, and it is in our range. So we are having 207 as the last student. So this is how we select the student by using a random number table. Question number 3. The probability that a certain spinner lands on red on any spin is P. The probability is P. The spinner is spun 140 times and it lands on red for 35 times. Find an approximate 96% confidence interval for P. Okay, this question is very straightforward. They are asking for a confidence interval for the P. Alright, so what is the formula? Okay, general formula for the confidence interval for P. Let's recall it here, yeah. The formula is P minus Z square root PQ over N. This is the lower limit. And after that, the upper limit in the interval is P plus Z square root PQ of N. This is what we have. Okay, then let us start, yeah. First of all, we need to find out the value for the P first. We are having 35 times of rate out of 140 times. So I take 35 divided by 140 to get the P, the probability or the proportion. And from this question, by right, you should get 0.25 in for the value of the P. Next step, we are going to find out the 96% confidence interval. And I can just directly apply the formula. I'm having the P here, so P is 0.25 minus the Z. Right, so we need to find the Z by ourselves. How to figure out the value of the Z? Basically, it's like this. When we are talking about a confidence interval, right, the 96% means that the center part is the 96%. And since we are having a normal distribution, right, okay, what is this about? This area will be 1 minus 0.96, then you get 0.02. Then this is also 0.02 because for normal distribution, they are symmetric to each other. When you add all these values together, it should be equals to 1. And we are interested to find the Z. There are two values here. Like this is the Z and this is negative Z. So to be more convenient, I just find out by using the Z. To find the Z, I need to use the normal distribution table in the reverse way by looking at this whole area that I label in blue color here. Right? Because when I'm having the probability of the equation of Z smaller than this value of Z, it should be equal to 0.98. Okay, 0.96 plus 0.02, so you get 0.98. Therefore, we go to the table and we find the table in the reverse way. That means I'm having the probability here, then I need to find the value of Z outside. And usually I will tell students first, if let's say you're trying to solve the question, right, the priority that you read the value, you should always look for the shortcut value here first at the bottom. Is there any 0.98 here? No 0.98, right? Therefore, only you go back to the previous part on top. If they provide you the shortcut value here, then you should use this one. It's much more faster, right? Okay, since I don't have any 0.98, so I'm looking it from the table on top. Please look for a value smaller than 0.98 but closest to it, which is this one. And if I read out the value, it should be 2.0. The value on top here is a 5, okay? 2.05. And I need to add a 2 at the last digit of the number, right? If I add a 2, there are two options here. One number is a 4 on top, another number is a 5 on top. So we're having two values, either is 2.054 or 2.055. Both values are accepted, okay? Go back to our calculation here, and now I know my Z is 2.054. 2.055 also can, yeah? Okay, so for me, I'm using 2.054. Then square root PQ over N. So P is 0.25, Q is 0.75, divided by the sample size. The sample size is 140. Then same thing happen, you apply for the upper limit, it will become a plus 0.25 plus 2.054 square root PQ over N divided by sample size. Okay, definitely when you press the calculator, right, they will give you a very long value as the final answer, but we have to cut it short into three significant figures where the answer should be 0.175 and also 0.325. Okay, don't forget to make it become the three significant figure answer. This is part A, right? Then let's continue to part B. Okay, so besides this one, now I'm having another three further experiment. Then they calculate 90% confidence interval, 95% confidence interval, and also 99% confidence interval. So find the probability that exactly two of these confidence intervals contain the true value of P. Contain the P. Right. For this part B, right, they only focus on these confidence intervals, yeah, where we only refer to these three confidence interval given here. Okay, and let's have a look for all this percentage here. 90% confidence interval, 95% confidence interval, and also 99% confidence interval. Alright, so a lot of students, they just know how to find out the confidence interval by just substituting the details into the formula and get an answer, right? But what's the meaning behind it? So 99% confidence interval basically means that it is 99% or maybe 0.99. It is 99% sure that the confidence interval contains the P. For this case, If let's say you found the mu1, it will be 99% the confidence interval contain the mu. Okay, so that means 1%, the confidence interval does not contain the mu, right? Or does not contain the p. So basically that's the meaning for the confidence interval, and you need to be aware of it. Right, we are having 3 confidence interval now. Okay, so this one, erase it. You're having 3 confidence interval now, and we are interested to know what's the probability if exactly 2 of these 3 contain of the mu. Alright, so we can consider what are the possible cases we have. Maybe the 2 confidence interval that contain the value p1 is the first and the second one. So the third one doesn't contain the p. Okay? Or maybe the first one contained the p, second one didn't contain, the third one contained. So next one is cross, then tick tick. Okay, so from here you can see that for every single case here, this is case number 1, this is case number 2, and also case number 3. Every single case here, there are 2 confidence interval that contain the p. Let's calculate the probability for the first case. For first confidence interval 90%, the probability of contain the p is 0.90. The confidence level actually means this one, right? How confirm that your confidence interval contain the true value of the p or true value of the mu, okay? Then for 95%, confidence interval contain the p is 0.95. 99% doesn't contain, so it will be 0.01. Alright, then the second part here, it will be 0.90, 0.05, and also 0.99. So I hope that you understand how I get all this value here. After that, the third case is the first one doesn't contain the p, so it will be 0.10. The second one contain the p is 0.95. Then the third one contain is 0.99. Then after you get the value for all the cases here, then let's get the total. Alright, so when you try to press a calculator, by right, the total value that you get, if you put it in the fraction form, it should be 2943. Wait, 2943 divided by 20,000. Okay, or if you want to make it into significant figure, it will be 0.147 correct to 3 significant figure. Alright, so this is how we calculate the probability, and we need to consider the cases by cases. We have to list out all the possible outcomes so that it consists, for every single case, it consists the condition where 2 confidence interval contain the p and 1 confidence interval doesn't contain the p. And this is how we solve the question number 3. Right, question number 4. A certain kind of firework is supposed to last for 30 seconds on average after it is lit. And inspectors suspect that the firework actually lasts a shorter time than this on average. Highlight the keyword shorter time. This is actually a keyword to help you set up the alternative hypothesis. For this question, it should be a test question, the hypothesis test question. So we'll see it later, yeah? Right. He takes a random sample of 100 fireworks. You're having 100 fireworks here, which is a sample, and each firework in the sample is lit, and the time it lasts is noted. Give a reason why it is necessary to take a sample rather than testing all the fireworks of this kind. If you try to imagine, yeah, when you want to run a test for this kind of firework, right? If you try to lit all the fireworks in the population, what will happen? All the fireworks cannot be used anymore, right? Which is not practical, right? Yeah. Therefore, the reason is we have to use the sample because of the fireworks will destroy when it is tested, right? So you can just write fireworks are destroyed. Because once it is lit, then you cannot use it anymore when tested. Therefore, we can only choose a sample to run the test, but you cannot use every single firework in the population to carry out the test. This is the reason. Then let's continue further. It is given that the population standard deviation of the times that the firework of this kind lasts is 5 seconds. Highlight the keyword 5 seconds here. This is the population standard deviation. The mean time last by the 100 fireworks in the sample is found to be 29 seconds. Okay, mean time, highlight the keyword mean time, highlight the keyword 100 fireworks. This is the mean. And what does the mean here means? Okay, the mean here basically is the sample mean because they are talking about the sample for this, which is this 100 fireworks. Test the inspector's suspicion at the 1% significance level. Yeah, so like what I told you just now, it should be a testing question. Right, so let's start setting up the test. First step, you have to write out the null and also the alternative hypothesis. We are talking about the mean, right? The population mean, the average. Okay, then we actually don't know what is the distribution of this population, but because of we are having a very large sample here, which is 100 fireworks, and we can assume that according to the central limit theorem, we know that it should be, the sample mean should be approximately normal distributed, okay? And we can use a normal distribution to carry out the test. All right, and we already set up the alternative hypothesis line, which is a shorter time. Okay, so you need to know mu is equals to 30. We are going to test the population mean, 30 seconds. And because of the word shorter than, so less than 30 seconds. All right, okay, this is the first step. Second step, we want to know what is the critical value. For me, under the normal distribution, I will use the critical value. If you want, you can also proceed with this by using the p-value. So there are two options here because this is normally distributed. All right, so you can use the critical value, then or you can use the p-value. I'm using the critical value method here. To know the critical value, right, I will usually draw a diagram to help me lah. To me, I think I understand better if, let's say, I have something to visualize, okay, something to read or something to look. Okay, when I'm having a diagram, a graph, it is a normal distribution, so this is my normal distribution graph. This is a one-tail test on the left, therefore the rejection region is also on the left. Okay, how big is this rejection region? It is actually our significance level, which is 1%, so it will be 0.01, and the big area here will be 0.99. And I want to know what is this particular critical value, this one. Okay, so to calculate the critical value, I need to find out from the normal distribution table in the reverse way also, because we are having the probability and we want to find the value of the z. And in our table, they didn't provide you with the probability 0.01, so you have to look at the large probability, which is 0.99. Okay, let's have a look. Always start from the bottom table first. Do you have anything that's related to 0.99? So you can see that, oh, your probability 0.99 is here, and the z value is 2.326. Therefore, your critical value will be 2.326. But if you have a look for the diagram here, you should know that the center is a value 0. Therefore, this value should be a negative value. So you just directly put negative here. This is your critical value, which is negative 2.326. And if you try to observe from here, right, I also try to draw out the rejection region for my diagram. All right, so next one. After the critical value, let's continue to get the test statistic. What is the test statistic here? All right, so I try to calculate the test statistic. Test statistic formula is Z equals to, I'm using sampling distribution, right? So sample mean minus the population mean divided by standard deviation over squared n. What is the value for the sample mean? It should be 29 minus the population mean. This is the population mean, 30. Okay, divided by standard deviation, which is a 5 over square root n. So divided by square root sample size. Your sample size is 100. Your test statistic, if you use calculator, by right, the answer is negative 2. Okay, after you get your test statistic already, now next one, we have to make a decision whether you want to reject the null hypothesis or accept the null hypothesis. To decide, I have to put the -2 into the diagram here. I know that this critical value is -2.326, right? If I want to place my -2, it should be the line over here. This is a -2. Alright, then before you make any comparison, please don't forget to write a comparison statement where you should tell them that the test statistic, which is a -2, is actually greater than the critical value, which is -2.326. Correct? Then after that, from here, what should we do is, you look at the diagram that you draw just now. The -2 that we draw, right, falls under this white color area. So like what I told you just now, the shaded area is the rejection region. This white color area should be the acceptance region. And our decision will be we accept, which is do not reject. We do not reject the null hypothesis. Okay, this is your decision. Don't forget to make a statement, the conclusion statement, based on the context of the question. If we do not reject the null hypothesis, it means that the time is not less than 30 seconds. Right, so you can write a statement that's related to this one. So you can write that, oh, that is sufficient, also insufficient, because we do not reject the null hypothesis. So insufficient evidence to show that, or to support the inspector's suspicion. So this is how we carry out the test. Please make sure that you don't miss out any particular step here. First step is setting out the null and alternative hypothesis. Second step, try to find the critical value. Next one will be the test statistic. After that, compare the critical value and test statistic. Finally is the conclusion. Okay, yeah, this is what you have for part number B. And let's have a look for part C. So for part C, they are asking, state with a reason whether the central limit theorem is needed. Okay, in the solution for part B. I think I did mention just now, right? Yes. We have to apply the central limit theorem because we are using a normal distribution here. And why we need to apply the central limit theorem? Because we don't know, all right, the original distribution for the population. And if I use the central limit theorem, according to this CLT, the central limit theorem, it says that if your sample size is large, then your sample mean will be also normal. That's the reason why we can use normal distribution to carry out the test. Okay, so you can say yes, and then the reason is because the population distribution is unknown. Population distribution is unknown. Okay, this is how we solve question number 5. Question number 5. In a certain large document, typing error occur at random and also at a constant mean rate of 0.2 per page. Highlight the keyword per page. Usually I will tell the students when you're looking for a certain interval, right? They give you a mean in a certain interval. It will be basically the Poisson distribution. So you have to identify the distribution by yourself here. All right, so this is actually one of the main point that you need to know. All right, the mean rate is constant, and after that they give you the average, the mean for a certain interval. So our interval here will be per page, every single page. All right, find the probability that there are fewer than 3 typing errors in 10 randomly chosen pages. We are having 10 pages here. We want to calculate the probability that there are fewer than 3 typing errors. So what can we do is, first of all, you can define x is the number of error or the number of typing error. It is Poisson distributed like what I told you just now. And then the mean for one page is 0.2. But in our question here, I'm having 10 pages. So I have to multiply with the 10. 0.2 times 10, you get 2. And after that, I want to calculate the probability for x smaller than 3, fewer than. So fewer than, that means less than, no equal sign, 3. Okay, all right, so just recall again. What is the formula for us to apply to find the probability for Poisson distribution if the value is lambda, the mean is lambda, okay? If you want to calculate a simple one, the exact value, as example like x equals to r, the general formula will be e power negative lambda, lambda power r divided by r factorial. But if they want you to find some inequality like x smaller than 3, x greater equals to 5 and whatsoever, then generally this formula will be useful when you are looking for x smaller equals to r. The general formula is e negative lambda. X equals to 0 is always a 1. X equals to 1 is always a lambda here. X equals to 2 will be lambda square over 2. X equals to 3 will be lambda cube over 3 factorial. And you can continue this until x equals to r, which is lambda power r divided by r factorial. If you factorize out the e power negative lambda, later when you want to press the calculator, right, it will be much more easier and you will avoid a lot of careless mistake when you press the calculator. This formula is not provided in the formula booklet, but it is not hard for you to apply. You just try to remember that you take out or you factorize out the e power negative lambda will do. Alright? Now let's come back to our question here. We are having x smaller than 3. That means I want to include x equals to 0, x equals to 1, x equals to 2. Not include the 3, so 0, 1, 2. To write out the formula, what do I have here is e, negative lambda, so my lambda is a 2. First term, x equals to 0 is always a 1. X equals to 1 is always a lambda. X equals to 2 will be lambda square divided by 2 factorial. That's it. Okay, x equals to 0, x equals to 1, x equals to 2. But I factorize out the e power negative 2. Okay, press calculator, that's it. And by right, your answer is a long one. Please cut it short into 3 significant figures. By right, you should be getting 0.677. Okay, so this is how we get the answer for first part. Then let's continue to the part B. For part B, use an approximating distribution, highlight the keyword approximating distribution to find the probability that there are more than 50 typing errors in 200 pages. Alright, in our A2 syllabus, Stats 2, okay, we are having two types of approximating question. The first one is you are having binomial and you want to change it become Poisson. And what's the condition for changing binomial to Poisson? Your n must be greater than 50 and your NP must be smaller than 5. That's the condition. And the second type of the approximating question is you can change Poisson become normal distribution. When can you change Poisson become normal distribution? The condition is when your lambda is greater than 15. Okay, and for this question, you already can see that they tell you very clearly, I want you to use the approximating distribution. That means you must take some approximation. And this question originally is Poisson, right? Therefore, the second type of approximating will be our consideration here. I'm going to change the Poisson become normal. Okay, so let's start. Again, first of all, I'm having Poisson distribution, and then one page, per page the typing error is 0.2. And now I'm having 200 pages, so I have to multiply the 0.2 with 200, and this will give you an answer 40. And from here you can see lambda already more than 15, right? 40 is large already, much more larger than 15. What you can do now is you have to change it become normal distribution. When you change it become normal distribution, mean is 40, variance is also 40. Do you know why? Because for Poisson distribution, there's a very special characteristic for Poisson where the mean and variance are having the same value. Alright, therefore you can see that the mean and also variance is also the same in your normal distribution. Right, then next, you want to calculate the probability for x more than 50. The number of typing error is more than 50. How can you calculate the probability? This is the Poisson, and you need to know that for Poisson, right, it is a discrete random variable. For normal distribution, it is a continuous random variable. Discrete random variable, when you want to draw the diagram, it is a line graph, and there's gap between all the lines. When you draw the continuous graph, it is a curve, a smooth curve usually, and most of the time there's no gap between the curve. Alright, so when you want to change the discrete into the continuous random variable, you need to have a continuity correction. And the continuity correction is either plus 0.5 or minus 0.5. That means you are looking at the 50, right? There are two options only. Either it's plus 0.5 or either it is minus 0.5. So how can you decide? Usually for me, when I want to decide, I just imagine something like this. Okay, I imagine that I'm having a poison and I have a few bar line. Okay, the straight line like this. Let's say 50 is this one, then I'm having 51, 52, then 49 and also 48. Right, so if I have a look for this particular symbol, x greater than 50. When you want to calculate the probability for Poisson distribution, x greater than 50, does it include 50 or not? It is not, right? Because you can see that there's no equal sign here, which means 50 are not included, and your calculation is starting from 51. And I highlight the area on the right hand side of 51 because they say greater or equals to 51. So I actually highlight on the right hand side of 51. When you want to do the continuity correction, there are only two options, like what I told you. One is 50.5, another one is negative 0.5, okay, which is 49.5. Then you have a look. 50.5 is here. Okay, then 49.5 is here. Okay, so which one is the number that cover the whole area and closer to the whole area? So you can see that the particular line here, able to cover the whole area and it is closer to the whole area. Therefore, my continuity correction should be this one, which is 50.5. Okay, yeah, so after you do the continuity correction, that means you already changed the binomial become, the Poisson become normal distribution. And now let's calculate the probability. Okay, since we already know that it is a normal distribution now, so to calculate the probability, you have to change the x become the z. Okay, how to change it become z? You have to take the x minus the mean divided by standard deviation. Then try to get the value of z correct to 3 decimal places. It is 1.660. So why when you want to put it into the 3 decimal places? Yeah, because the accuracy for our normal distribution table for the value of z is up to 3 decimal places. So to get the most accurate answer, please keep your value of z into 3 decimal places before you want to find the table. Alright, the MF19, the table for MF19. Okay, then now I want to calculate the probability. Z greater than a positive value should be 1 minus, then I look for 1.66. 1.660, so 1.6, and then the 6 is this one. 0 means you don't need to do anything. So what's the answer here? 9515. Okay, go back to our solution. I will get 1 minus 0.9515. Then by right, this is your answer. Okay, this is how we solve the part B. Then let's continue to part C. In the same document, formatting error. Just now one is the typing error, and now they have another type of error which is the formatting error. Occur at random at a constant mean rate of 0.3 per page. So just now, for the typing error, I put the variable as the x, right? Maybe this one you have to label it as another letter, which is maybe the y. Okay? Find the probability that the total number of typing and formatting error. Total means that you are interested to find out the x plus y in 20 randomly chosen pages. Okay, so first of all, I need to get the lambda or the mean, the total mean for 20 pages first. Okay. All right, for one page, the mean should be 0.2 plus 0.8, right? The mean for the error. This is for one page. The total error can be having is typing and formatting error. So the mean should be 0.2 plus 0.3 for one page. But now I'm having the 20 pages. Therefore, I have to multiply with 20. And I will actually get 10. Okay, my lambda is equals to 10. And they are interested for this value. The total error is between 8 until 11. Inclusive. Highlight the keyword inclusive as well. The word inclusive tells you that you must have the equal sign for the 8 and also the 11. Okay, then continue. From 8 until 11, what does it mean? It means that you need to start from x equals to 8 and at x equals to 11. So e negative lambda, like what I told you just now, factorize out the e negative lambda, then start from 8. So you're having lambda power 8 divided by 8 factorial, lambda power 9 divided by 9 factorial, lambda power 10 divided by 10 factorial, and also lambda power 11 divided by 11 factorial. Okay, so by using a little bit help from calculator, if you didn't do any careless mistake, right, the answer for this one should be 0.477, correct to 3, significant figure. Yeah, so this is how we answer the question number 5. Question number 6. A machine is supposed to produce random digits. Bob thinks that the machine is not fair and that the probability of it producing the digit 0 is less than. Highlight the keyword less than. Again, this is a test question and this will be your keyword to set up the alternative hypothesis. Alright. In order to test his suspicion, he notes the number of time of the digit occur in 30 digits produced by the machine. He carries out a test at the 10% significance level. State suitable and also the null and alternative hypothesis. Right, so I think the keyword is there already and it is very obvious. We want to carry out the test on the proportion. Originally, we thought we will think that the proportion should be equals to 1 over 10, but Bob thinks that it should be less than 1 over 10. Therefore, the alternative hypothesis will be less than 1 over 10. So the keyword comes from the question, yeah, you can see the keyword less than. Alright, then now they say they want you to find the rejection region for the test. Let's have a look for the significance level first. The significance level basically is 10%. 10% means that it is the area, how big the area for the rejection region. Okay, alright. And if you want to find the rejection region for the test, yeah, you need to know that when you want to carry out the test for any proportion, the distribution that we are using is binomial distribution. So for this case, yeah, where is my parameter for the binomial distribution? So you can see that he tried to inspect the digit 0 occur in 30 digits. So your n will be 30 in the binomial distribution. And the p is actually 1 over 10. Okay, so when you want to carry out the test here, for any proportion here, we are using the binomial as a distribution to calculate out the probability. Okay, then now I want to find the rejection region. Maybe before I find the rejection region, I try to draw a simple diagram to help me and visualize the detail first. Yeah. Okay, this diagram that I show you here cannot be shown in the exam because it is not the correct diagram. Okay, but it's just to help us to understand it easier if let's say you need something to help you. If you can't visualize, right, then you can use these small tools or maybe the small diagram here to guide you. But again, you cannot draw this in the exam. It is not the correct diagram actually, right? Okay, I'm having binomial distribution and I label the beginning of my bar here is 0 and then the end will be the 30. And this is a test on one tier, right? One tier test on the left, smaller than. So I draw a rejection region on the left. And also, this one, I try to put it for, label it as 0.1 because 10%, so 0.10. Alright, and now to calculate or to find the rejection region for the test, I want to know, okay, for my value of x, which one falls under the rejection region and which one falls under the acceptance region. And usually we will start from the value of the x that is close to the rejection region. So like my rejection region is on the left, right? So when we want to carry out when we want to find out the rejection region, we start from the left hand side. If your rejection region is on the right, then later when you want to calculate the probability to find out the rejection region, then you have to find out from the right. Understand? Okay, so we are having the left. Therefore, I start from the left. I start from the smallest value first, and I know that this smaller equals to 0 definitely is inside the rejection region, but I still need to calculate it out. So how can I calculate the probability for x smaller equals to 0? It will be 30C0, 1 over 10 power 0, then 9 over 10 power 30. Alright, when we try to press the calculator, right? So by right, you'll be getting 0.0424. It is a very small value, but if I try to compare it with my rejection region, then it should be less than 0.10. So less than 0.10 means that if you want to label this clearly, maybe the 0 is here and this whole probability here. Okay, for the 0 is 0.0424. And you can see 0 falls under the rejection region. Okay, all right. Yeah, so I usually label 0 at the side here. Okay. Then now, 0 is in the rejection region. Then how about the 1? Is 1 in the rejection region or not? So to calculate it, I have to calculate the probability for x smaller equals to 1. Therefore, I'm having 0.0424. This is x equals to 0, right? Then plus x equals to 1. So 30C1, 1 over 10 power 1, 9 over 10 power 29. When I press calculator for this, the answer that I get is 0.184, which means that it is greater than 0. Greater than 0.10. Greater than 0.10. If you try to draw x smaller equals to 1 equals to this in the diagram here, so take note this one. 184 is greater than 0.10, right? When you want to label the area, so this area that you label should be more than 0.10 because 0.184 should be bigger. The area, the black color area is bigger compared with the smaller area for 0.10. And you will see that if I draw the area like this borderline here will be the 1 because on the left we are calculating the probability for x smaller equals to 1. So that means this black color area is a area or the probability x smaller equals to 1. And from here you can see that the borderline 1 actually falls under the acceptance region. Can see that? 0 is inside, but 1 already outside because compare the area that you calculate for x smaller equals to 1 with the significance level, it is bigger than it. So when you draw an area bigger than it, you can see that the 1 falls under acceptance region. Alright? Okay, then how about 2, 3, 4? If let's say 1 falls under the acceptance region, then you need to carry out for 2, 3, 4 already. All the 2, 3, 4, 5, 6, and 13, they are all under the acceptance region as well. Okay? And from here, what can you see? They want you to find the rejection region, right? So you have to put the final answer for this part. So what's the rejection region here? There's only one value that is included or it is located under the rejection region. And it is actually x equals to 0. If you want to put x smaller equals to 0 also can. Alright, but because we are talking about this, right? All the value of x should be the positive value. Okay? So x smaller equals to 0 also no problem. If you want to keep it as x equals to 0 also can. And don't forget this is my rejection region. And 1, 2, 3, 4, 5, 6 until 30, it will be our acceptance region. Okay? Then I want to emphasize again, this particular diagram cannot be drawn in the exam because it is not a correct diagram, right? This is what you have for part B. Then let's continue to part C. State the probability of the type 1 error. Okay, what is the probability of type 1 error? And they ask you to state only. Okay, let us have a look for the type 1 error definition first. Type 1 error definition is reject the null hypothesis when the null hypothesis is true. Reject the null hypothesis means that you have to put in the rejection region. So we just now already know that rejection region is x equals to 0, x smaller equals to 0. And then the null hypothesis is true means that you are using the p equals to 1 over 10. Okay, when p is equals to 1 over 10, it also means that you are using the binomial distribution for the calculation, 30 and 1 over 10. Okay, so what's the probability for this one? The probability for x smaller equals to 0. If you try to scroll up just now, you already get the probability for x smaller equals to 0, right? It is actually 0.0424. So actually, you already get the type 1 error just now, which is this. Okay, so we are having 0.0424. Alright, then let's continue to next part. Part number D. It is now given that the machine actually produces 0 once in every 40 digits on average. And now if you read this sentence, they are telling you that, okay, now I realize that my P is actually really got a different value. And it is once every 40. That means the P now become 1 over 40 instead of 1 over 10. And they want us to find the probability of a type 2 error. So first of all, we need to know what is the definition for type 2 error first. For the type 1 and type 2 error, right, you need to think a way to memorize it, because it will not be provided in the formula booklet. You need to at least remember or define, know the definition, the basic definition for type 1 and type 2 error. Okay, so type 2 error is accept the null hypothesis when the null hypothesis is false. Okay? Accept null hypothesis means that you have to put in acceptance region. So where's your acceptance region? Just now, your rejection region is x equals to 0. Therefore, acceptance region means the opposite of this, right? And if I want to write out the acceptance region, it should be x greater equals to 1. Because from 0 until 30, right, only 0 belongs to the rejection region. So the rest of the number belongs to acceptance region. So when you want to write out, it should be x greater equals to 1. Okay, then null hypothesis is false. Just now, our null hypothesis is p equals to 1 over 10, and this is false. To calculate the probability, we need another value. Null hypothesis is false means that this is true. But p is more than 1 over 10, right? There are many possible values, right? That is the reason why in this question, they give us one value of the p here, which is 1 over 40. So you double check and see. Basically, you can see that 1 over 40 is a value that is less than 1 over 10, which fulfill the alternative hypothesis. Okay? Alright. And usually, after I write out the definition for the type 2 error, I will write out the distribution for myself to remind myself what is the formula that I should use. So when we are trying to test the population proportion, we are using binomial distribution as a calculation for the probability. And I'm still having 30 for the n, and also the p now become a new p, which is 1 over 40. Okay? And now I want to calculate the probability for x greater equals to 1. How should I do the calculation? I have to start from x equals to 1, x equals to 2, x equals to 3, and so on. So there are so many, right, until 30. The easier way will be I take 1 minus x equals to 0. So x equals to 0 means 30, C0, 1 over 40. So please use the new p now, 1 over 40 power 0, and also 39 over 40 power 30. Okay. Then from here, when you try to press the calculator by right, you should get 0.532 if I'm not mistaken, right? And this is correct to 3 significant figure as well. Right? Yeah. Then again, to calculate the type 1 and type 2 error, you need to at least remember the definition of it. Then only you know how to continue with the calculation. Alright, then last part for this question, part E. Explain the meaning of type 2 error in this context. Okay, so before that, I try to write out my null and alternative hypothesis again. null hypothesis is equals to 1 over 10. Alternative hypothesis is less than 1 over 10. Type 2 error, the definition is accept the null hypothesis when the null hypothesis is false. Okay, accept the null hypothesis means that we accept we conclude that the P is equals to 1 over 10. All right, so what you can say that is we conclude that P is equals to 1 over 10, although it is null hypothesis is false, that means it is not true. So although in fact it is not. So this is how we explain it in the context of the question. All right. Yeah, so I think this is the end of the chapter 6, and hope that you understand this question. All right, so the very last question for this paper, question number 7, the probability density function of the random variable x is given by the function like this, and the value of x defined is from 0 until 2, okay? Where k is a constant, they want us to show that k is equals to 3 over 16. All right, for any continuous random variable, right, if you are having the probability density function, then we should know that the integration for all the values of x, okay, for the function fx, that means the area under the graph should be always equals to 1. And this is very useful, especially when you want to use it to find any constant in the function itself, right? And you can have a look here. We are having the constant k inside, so we are going to use this particular concept to find out the k. And the integration for all x means that I have to integrate the function from 0 until 2 because it is defined from 0 until 2. The function fx is this whole thing. And I will need to let it equals to 1 because I know the area under the whole graph is a 1. Then k is a constant, I prefer to take it out. To integrate this, we have to multiply the x inside into the bracket first. Then only you can start the integration. So integrate 4x, you'll be having 4x squared divided by 2, which is 2x squared. Then x power 2, you add 1 to the power divided by the new power 3. So you're having a 2 and also 0. Okay, then try to substitute the value inside. 2 squared times 2 is 8. 2 power 3 is also 8. Okay, then 24 minus 8, you'll be having 16 over 3. Therefore, you can see that we successfully get a k value which is equals to 3 over 16. Alright, yeah, this is quite easy, right? It is actually the simple concept here. Okay, then let's continue to part number 2. For part number 2, they want us to find the expected value of x. To find out the expected value of x, the general formula is state integration, but before you integrate, you have to multiply the x together with the function. Okay, so for your extra information, if let's say I want to find the expected value for x squared, then you need to multiply x squared together with the function before you can integrate it. So that's the concept, right? Okay, now I want to find the expected value of the x. I need to multiply x squared into my function for all the value. Oh, sorry, I have to multiply the x and not x squared because you are having ex, so multiply the x with the function. Where's the function that I have? 3 over 16, which is the k that we found just now. Then 4 minus x. Okay, 3 over 16 is a constant. For me personally, I prefer to take it out. Then before you can integrate it, we have to multiply all the x into the bracket, and it results in this one, 4x squared minus x power cube. Then now only I start the integration. Next, I try to substitute all the value in. I'm having 2 power 3 is 8 times 4, 32. So 32 over 3 minus 2 power 4 is 16 over 4. Then if you substitute 0, everything will be 0 there at the back. Then simplify this answer by right, you will get 5 over 4. Okay? Yeah, so this is not hard as well, as long as you're very careful when you apply the integration. Then let's continue to the last part. Last part is the part B. The random variable y has a following property. Y takes value between 0 and 5 only. The probability density function of y is symmetrical. Given that y smaller than a is 0.2, then find this particular value, illustrating your method with a sketch on the axis provided. Okay, so for this axis, right, they provide us with 0 until 5, but that means I have to draw some the probability density function of the y here. And they didn't tell us what is the function, but basically they just let us know that we are having the probability density function which is symmetrical. Okay, so I don't know how is the probability density function, so I just simply draw any pattern, okay, or any graph that is symmetrical. If let's say I want to have a symmetrical graph, right, that means the symmetrical line will be at 2.5, because from 0 until 5, the center line is at 2.5. So this is like a mirror. Maybe I just try to put the highest point of the graph at 2.5 lah. Okay, it can be any other thing else as long as the graph is symmetry. All right, you can be having a curve, a normal curve, look like a normal curve, or you can have a certain shape. For me, I plan to just draw it using a triangle, and this is how my triangle look like. Okay, so you have to take note that for this 2.5, but it is the midline, the symmetrical line for the whole graph here. Okay, and you need to know also for any probability density function, right, the area under the graph is a 1. So what happened if let's say I want to find the area for the first triangle here below the 2.5, so this first area triangle will be 0.5, then this one should be also 0.5 because they are symmetrical, right? Okay, then let's have a look for the question here. They said, I give you the idea where the y smaller than a is a 0.2. 0.2 is a small value, small area. Therefore, I should expect that the a is somewhere here. And then if I try to plot the area below the a, smaller than the a, this particular value here, this particular area here, it should be 0.2. Okay, and this is a, from 0 until here, the distance here is 8. Okay, and I already know this area is 0.2. How can I find out the probability of y is between 2.5 until 5 minus a? Alright, so let's have a look for 5 minus a first. Yeah, this looks a bit hard to understand, right? 5 minus a. So 5 minus a means that you are taking number 5 minus the a. What is the distance of a? It looks like this. So you assume that you have also one value here where the distance of it away from the 5 is the a. So by right, this is the value for 5 minus a. And since we already know that just now, our graph is symmetrical, right? Okay, therefore, the area for smaller than a and the area for greater than 5 minus a should be the same. So I can label this as 0.2 as well. Okay, then what else do I need? Maybe now I try to look at my diagram here. We are interested to find 2.5, the area for 2.5 until 5 minus a. So that means I'm interested to find out the highlighted area here, this one. Between 2.5 to 5 minus a is this. And then now my question is, how can I find out this area? So to find the area, what I can do is that I can find the area for y greater than 2.5 first. Y greater than 2.5 means the green color that I draw now, the triangle. This is y greater than 2.5. Then minus the small triangle, shaded small triangle on the right hand side. So this one, when I write it out, it should be y greater than 5 minus 8. What's the probability for y greater than 2.5? So just now it is, I did tell you that 2.5 is the center line, right? So all the whole area above the 2.5 should be 0.5. Half, okay, so 0.5 minus this small area here, and I told you just now, it is symmetrical. Therefore, it is same as the line, the probability for y smaller than a. So you have to minus the 0.2, and this is how you get the answer 0.3. Okay, so for this question, there's no there are more than one way for you to get the answer. So for what I show you here, it is just a suggestion. Some students might ask, can I draw a normal curve here? No matter what kind of curve you want to draw, can, no problem, but you have to make sure that the symmetrical line is at 2.5 and also the graph is symmetrical. All right, yeah. So this is the end of the whole paper. All right, so thank you very much for watching the video. And if you found that the video is useful, please ask your friend to subscribe this channel. Thank you very much.